Hi. Let's continue with the next subtopic where we have electric potential. Let's look at what is the meaning electric potential. For example, we are given a point charge here, and as we know, positive or negative charge always surrounded by electric field. Maksudnya, tak kira lah charge positif atau negatif, di sekeliling charge yang positif atau negatif, kita sentiasa ada medan elektrik. And for information, any point inside electric field actually has a specific value of electric potential. For example, at this point A, the electric potential at this point is actually, for example, 50 volts. And for a positive point charge, further away from a positive point charge, we found that the value for the electric potential is actually decreases. For example, at point B here, the value for the electric potential here 30 volts. And we are not only not only point A and B has the value of electric potential. Any point in the electric field actually has a specific value of V, means has specific value for electric potential. So why is it important? By learn electric potential, if I have the value of the electric potential, and for example, if I want to transfer a charge from infinity to point A, so what I'm going to do, I can use the electric potential at point A times with the test charge that I bring. Then I can find the work done to transfer the charge. Okay? Maksudnya dengan guna nilai electric potential pada point ni, kalau saya guna nilai ni darab dengan nilai charge, nilai test charge yang saya bawa, maka saya boleh tahu berapa kerja yang dilakukan untuk saya gerakkan charge uji dari infinity ke point A. Okay, so that's important of electric potential. So what is the definition? Okay, for information, what is the definition for electric potential? Okay, so you should know how to define it. So for information, electric potential means V is, maksudnya equal, is the work done, okay, ini work done yang kita ada, per unit charge, means per magnitude of test charge that we bring, okay, bring from where to where. Kalau itu definition ni, we are actually bringing the positive test charge from infinity to a point, okay. Jadi ini definition untuk electric potential. Alright? And what is the formula for electric potential? Beside this formula, okay, we also can use for information. If you do some derivation on the formula for the work done, you kena pati sebenarnya kita ada cara untuk buat derivation lah, but it's not in your syllabus, okay. Jadi kalau you guna formula work done bahagi Q naught, the equation that you can get for in order to find V is actually V actually equals to KQ divided by R, and this Q actually refer to the charge that create the electric field, right? Ini adalah Dalam case ini dia bukan merujuk kepada charge uji ya. Bukan charge yang kita bawa, tapi magnitude of this charge actually referring to who create the electric field. So in this case, okay, siapa yang menghasilkan medan elektrik ini, positive point charge ini. Alright. So nilai charge ini yang kena masuk ke dalam sini. Is actually similar to, okay, is similar to what you learn in semester 1 gravitational field. Alright. So in this case, this Q actually referring to which charge is creating the electric field. Jadi kita ada ini. Alright. So let's continue with the exercise. So the possible calculation that they will ask in the exam will be calculate the resultant electric potential at point A, for example. Alright. So let's look at this case. For example, here is point A, and given in the question, we have 2-point charge. Okay, for example, Q1, okay, kita ada dekat sini, charge untuk ini, jarak di antara ini dengan ni, 1 cm, and we have Q2 here, Q2 with the sign negative. So for example, kita ada ni, kita ada point charge yang kedua dekat sini, dan jarak ini contohnya 2 cm. And we are asked to find what is the resultant electric potential. So as we know, electric potential actually stands for capital V. Alright? So you should know electric potential is a scalar quantity. Means, okay, before this in the calculation that we learned before, for example, force or electric field, both are vector, right? So when we want to find the resultant vector, what we do, the step 1, we always determine the direction for the force or electric field strength, right? But in this case, do we have to, in step 1, do we have to determine the direction for electric potential? We found that no need, because it's a scalar quantity. Alright. Jadi untuk ini senang je, tak payah lukis apa-apa anapana atau consider arah electric potential. Tak payah, sebab electric potential memang tak ada arah. So you just have to find its magnitude. So electric potential at point A, for information, as I say before, electric potential is actually depends mainly on who create the electric field kan. But in this case at point A, kita ada ni, kita ada point charge nombor 1, kita juga ada point charge nombor 2 kan. Dua charge ini memang mempengaruhi point A. Jadi maksudnya dekat sini untuk kita kira VA, kita pakai ni ya, K, Q over R. But we are not only have to consider charge 1. You have to add on, sebab resultant memang bermaksud hasil tambah. Okay? Tapi tak payah ambil kira arah mereka, jadi tak ada sign positif atau negatif kat sini. So you kena ambil kira ini. Ambil kira electric potential yang dihasilkan oleh point charge nombor pertama tambah lagi KQ2OR. Okay? Buat begini je. Kemudian, okay, selepas tulis formula ini, apa yang you buat? Ganti je apa nilai semua ini. But remember, okay, for scalar quantity, contohnya charge Q2 ini with the negative sign, right? You must put the negative sign inside your formula. Okay, ini you kena ambil kira sign of the charge when we add on this. Okay, because okay, you should know this one is actually scalar quantity. Jadi nilai K ni berapa? 9 exponent 9. Apa nilai Q1 dekat sini? We know 1 exponent negative 6 divided by R 1 cm. Tambah lagi 9 exponent 9. Q2 must substitute in the sign for the charge. Divided by distance is actually 2. Okay, so that's how we solve this problem. Alright. So after using calculator, the answer for this one is 0. Okay. So that's all for this video.